Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your test number 2 solutions. Question 1, a bar magnet has a north and south pole. That's true. Question 2, ferromagnetic materials are not easily magnetized. That's false. Question 3, the sum of the voltage drops in a series circuit will always be larger than the supply voltage. That's false. Remember, in a series circuit, the sum of the voltage drops have to add up to equal the battery voltage. Question 4, in a series circuit there is only one path for current flow. That's true. Question 5, in a parallel circuit there are multiple paths for current flow. That's true. Question 6, Ohm's law allows us to calculate either voltage, current, or resistance based on the data provided. That's true. Question 7, the power supplied by a voltage source in a series circuit is always less than the power dissipated in the circuit. That's false. Power supplied always equals power dissipated. Question 8, permanent magnets are magnets that do not require any power or force to maintain their magnetic field. That's true. Unlike an electromagnet operates on the principle of current through the conductor to generate that magnetic flux. Once the current flow is shut off over a period of time, the magnetic flux disappears. Question 9, magnetic lines of force are called flux. That's true. Question 10, an electromagnet is one example of a permanent magnet. That's false. Question 11, a voltage divider circuit is a resistive network where voltages are dropped across specific resistors. That's true. Question 12, two 6-ohm resistors are connected in series across a 12-volt battery. What is the voltage drop across each resistor? So I've set up the series circuit with V sub T, the total voltage for the battery is 12 volts, R1 is 6 ohms, R2 is 6 ohms, and I've given a symbol for current flow, conventional current flow. So the first step is we have to use Ohm's law to solve for the current I. I is equal to V divided by R, but specifically V sub T divided by R equivalent. Remember, in a series circuit, R equivalent is you add all the resistor values together. So R1 plus R2 is going to be 12 ohms. Voltage is 12, so 12 divided by 12, 1 amp of current flow. Also remember, in a series circuit, the current is the same through each resistor. So now I'm going to use Ohm's law again to solve for VR1 and VR2. The voltage drops across resistors 1 and 2 respectively. So VR1 is equal to I times R1. Current is an amp. R1 is 6 ohms. Gives us a voltage drop of 6 volts. VR2, same approach, equal to I times R2. Current is still an amp. 1 amp multiplied by 6 ohms gives us 6 volts. Question 13. Calculate the equivalent resistance in the circuit that contains 10 2.25 ohm resistors connected in series. Since they're in series, all we have to do is take 10 and multiply by 2.25 and we'll get 22.5 ohms. Question 14. If the current through R1 in question 13 is 1.5 milliamps, what is the current through R9? Remember, in a series circuit, the current is the same through each resistor, so it will be the same value of current, 1.5 milliamps. And lastly, question 15, a DC resistive circuit has a 5 ohm and a 7 ohm resistor connected in series with the 12 volt battery. Calculate the following parameters: Req, I, VR1, and VR2. So first thing to do always is draw the diagram. So I have a battery voltage of 12 volts specified as V sub T, R1 is 5 ohms, R2 is 7 ohms, and I label a direction for current flow. So first step, I like to calculate R equivalent. R equivalent is equal to R1 plus R2, so 5 plus 7 gives us a total equivalent value of 12 ohms. To solve for the current in the circuit, I'm going to use Ohm's law. I is equal to V divided by R, but again, specifically V sub T divided by R equivalent. So 12 divided by 12 gives us 1 amp of current flow. And then the two voltage drops. VR1 is going to be equal to I times R1. The current we calculated is an amp multiplied by the 5 ohm resistor, gives us a 5 volt drop. VR2, same current, I times R2, so 1 times 7 gives us 7 volts. And just as a check to make sure we're okay, remember the sum of the voltage drops in a series circuit have to add up to the battery voltage. 5 plus 7 will return the 12 volt value. Thank you.